Hey guys, how we doing? So I'm going to go ahead and take a few minutes here, and I'm going to go through the Desmos review with you. So if you've gone through it and you're struggling on any of the particular sections, just not sure what to do, then take a look at this video, and I'll walk through through each step at a time. All right. We'll kind of talk about and review some of those different topics. If you still don't get it after watching the video, I'll have a review session before we take the test on Thursday. Okay. All right. So here we go. You're going to click on Topic 8 Test Review if you haven't done this at all. And I'm going to go through the student preview here. So just so you know, you probably saw this at the beginning if you've already looked at it. But you basically have to sign here saying that you are going to take this test on your own using nothing but your own knowledge. However, I did say you are allowed to use the notes that were provided to you by me on the website. So any of the notes, the videos, anything that I provided on the website, you can use. Okay, but you cannot use any of your Google Photomath, anything like that. You can't use. All right, so all you have to do before you can take this test, before I'll even grade it, is just write your name right in here. Okay. All right. So getting started on this review, I'm going to go to the next page. We're going to take all right. So the next three pages are all reviewing section 8.1, all right, which are all just talking about key features. And so before we go through this card sort, I'm just going to kind of draw one quadratic up on the graph. We're going to take a look at all those individual key features, and then we can kind of break down and take a look at the card sort here. All right. So when I look at a quadratic, let's say I've got my coordinate plane right here. All right, and I've got my all right, so let's say I've got one. It looks like this. Okay. On this first page, the only thing that we're taking a look at, the only feature that we're paying attention to is the vertex. Okay, and so remember, the vertex is either the lowest or the highest point on the graph. It's the point where the graph changes direction. Let me fix that just a tiny bit. All right, so here my vertex is this point right here, which is the point -3, 2. Okay, so on this first page, okay, what you're looking at is we're trying to match up all of the specific vertices with their graph. So just taking one graph at a time. If you click on the graphs, you can actually zoom in on it. It'll give you a bigger view. And so like right here on this one, I can see maybe. It's going to take a second, I guess. Okay, so here I can see that my vertex is at a -1, -3. All right, so I'm looking at the -1, -3, which I've got it right here. I'm going to click and I'm going to drag over top of the graph. Let go, and they will be synced together. Right? So those are paired. I don't need to do anything else with those. So now we're just going to work with the rest of ours. So this one right here is 1, 3. So I'm going to find the vertex 1, 3. And I'm going to drag it, and that's my card sort. All right, we've got two more. This one right here looks like it's a -3, 1. And this one looks like it's 3, -1. Oh, oops, they all went to that one. All right, so we've used all of our cards. Okay, we're good to go to the next slide. And you can always go back and change things if you feel like you did something wrong. All right, going to the next one. All right, so now this one, we're talking about the y-intercept and the axis of symmetry. Okay, so the y-intercept is the point where the graph crosses the y-axis. Okay, this right here, this is my y-axis. Okay, now the key thing to remember with the y-intercept is that the x value is always 0. Okay, now here, my graph isn't necessarily going to, we can't see it crossing. We could anticipate, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe. All right, it might cross at 9. So we could approximate to say 9. All of your graphs you're going to be able to see. So we're just going to go ahead and say 9, but it's kind of hard for us to tell. Okay. So now that's the y-intercept. The other thing that we're looking for is the axis of symmetry. Okay, the axis of symmetry is the point that divides our graph into two symmetrical pieces. Okay. Now the key thing with the axis of symmetry, right, is that the axis of symmetry, it is a line. But the easiest way to remember how to write the axis of symmetry is because the line goes through the x-axis. So my axis of symmetry is x equals whatever x values it goes through. And so in this case, the axis of symmetry is x equals -3. All right, so let's take a look and see if we can match these up. Now, there is a special note on this one that says there should be 3 cards in each group when you're finished. All right, so each graph should have a y-intercept and an axis of symmetry. All right, so I'm going to start off with this graph right here. It looks like it has a y-intercept of -1, which is right here. My internet's acting kind of slow, so everything's kind of lagging. All right, and the axis of symmetry looks like it's at -1 as well. All right, so it says we have 3 cards, so we should be good to go. All right, there's 3 cards right there. Let's go look at the next graph. All right, this one looks like it has an axis of symmetry of -2. Got axis of symmetry of -2 right here. And it has a y-intercept. Looks like it's crossing right through there at the origin. So it's 0, 0. Move this graph into the open. All right. I'm going to look at this one right here, right? Looks like it has an axis of symmetry at +2. X equals +2. And its y-intercept, here's origin, here's 2. Looks like its y-intercept is 3. And if you're having trouble seeing, remember, you can always click on the graphs and it'll zoom in on them. Right? Which we only have one axis of symmetry and one y-intercept left. So we want to double check. This one has an axis of symmetry of 1. Oh, yeah, I don't think this one definitely has an axis of symmetry of 2. And looking back at this one, it's got a bunch of little middle marks. So this is 2. This one has an axis of symmetry of 1. So I mixed those up. Okay, so this one has an axis of symmetry of 1, and this one's going to be of 2. So we got to switch those. All right, and then my y-intercept of 5. Looks like it does have a y-intercept of 5. All right. Going to the next slide. All right. Last slide for section 8.1. Talking about intervals of increase and decrease. Markers. Okay, interval of increase and decrease. So what we want to look at, so we talked about, when we talked about these, it's been a little bit since we've been back in school, but if we follow a graph, right, we always follow a graph from left to right. That's how we read it. So if we follow from the furthest left, here on the left side, I'm going down. Okay, so that means I am decreasing. I am decreasing until I hit that axis of symmetry. Okay, so we can say that our interval of decrease is anything on the left side of that axis of symmetry, or when the x values are less than -3. Because my axis of symmetry is -3, okay, we are decreasing on the left side of that axis of symmetry. So we say we are decreasing when x is less than -3. Now, when we pass that axis of symmetry, we are increasing. So we say my interval of increase is when we are greater than, when the x values are greater than -3. Okay. So for each graph, we're only going to focus on one number, but we got to make sure that we get our interval of increase and decrease correct. So I'm going to focus on this one right here first. And we can see that my axis of symmetry is 5. Okay. Now on the left side of it, when x is less than 5, we are decreasing. Okay, I'm going down. So my interval of decrease is when x is less than 5. So I'm going to drag this card, put it over top, which means that on the other side of the axis of symmetry, when x is greater than 5, we are increasing. All right, taking a look at the next one over here. Looks like my axis of symmetry is a -4, right? And so we are decreasing first on the left side. So we are decreasing when x is less than -4. And we are increasing when x is greater than -4. All right, I'm going to take a look at this one down here. If my mouse will move. All right, so it looks like here my axis of symmetry is -4, but on the left, we're going up. So when x is less than -4, I am increasing. And when x is greater than -4, it's going to increase. All right, we only have 2 cards left, so I'm going to just double check to make sure that they go with the appropriate graph. All right, so I got an axis of symmetry at 5. On the left side, this part right here, we are going up. So it should be an interval of increase whenever x is less than 5. And that's what we have left. And my interval of decrease is when x is greater than 5. All right, so we've got all of our cards sorted out. Okay, so you can double check, make sure you like all your options, and then we're ready to go on to the next slide. Okay, so the next section, that's our last section for section 8.1. Next, we're going to go on and we're going to take a look at section 8.2. All right, so 8.2 is talking about the vertex form of a quadratic. Now, the vertex form of a quadratic is this right here, all right? So some key things that we can find here. First off, we can find the vertex from the H and the K, right? Now, also, we can find the axis of symmetry using solely the H value. Okay, it's the X value of the vertex, okay? So those are the things that we're looking for. The A value tells us how to find our second point. Once we plot the vertex, it tells us how to find the second point. So what we're looking for here is we're trying to figure out which one of these represents this graph, right? So what I want to do first is I want to find the vertex. Okay, so my vertex here is 5, 1. So I want to find out, using this formula, when I put 5 in for h, we'll have x minus 5. And then 1 is my k, so it'll be x minus 5 squared plus 1. So this right here is going to be my option. Okay. All right, move on to the next slide. All right, this one, select the vertex for the following. Now, this one, it gives us the vertex form, and we have to try to find the vertex. So we want to focus on two things when we're trying to find the vertex. Obviously. Come on. You want to say hi? Come on. No? Okay. Sorry, I thought my dog wanted to say hi. He doesn't. So anyway, okay. We've got this value right here. That's our h, okay, which tells us the x value of the vertex. Right? But now, the key thing here, remember, in my formula of x minus h, okay, notice how there's a minus h here, but a positive h here. What that means is the x value of the vertex is always opposite of what we see in the formula. Okay, so here, if I have a minus 6, that means the x value of the vertex has to be a positive 6. In our multiple choice here, we only have one option that has that positive 6. So, but we want to double check just to make sure. This has a positive 2 as the y value, positive 2 as the y. So my vertex is 6, 2. All right, so we select 6, 2. This question wants you to explain your thinking, right? So you'll only get partial credit if you get the correct answer here, but you've got to explain why you chose that answer, right? And because I'm going to say the x value of the, not in here, the x value of the vertex is found in the parentheses, but it is always opposite. The y value is found outside the parentheses. Okay. All right, so you need to give it just a basic explanation as to why you chose your answer. Okay. All right, which of the following represents the axis of symmetry for the following quadratic function? Well, axis of symmetry is the x value of the vertex. So the same way that you found the vertex, you're going to find the axis of symmetry, but we only need the x value. So we have a positive 8 here, so the axis of symmetry is negative 8. You don't have to explain your thinking for this one. All right, so that was it for 8.2. Next, we're going to take a look at 8.3. This is standard form. Standard form of an equation is y equals a x squared plus bx plus c. Okay, this particular problem wants us to find the axis of symmetry. Which we already know is the x value of the vertex. Well, to find the x value of the vertex, and it gives it to us here, we need to show how we can use the formula x equals negative b over 2a. Okay? All right. So negative b over 2a. First off, we have to know in this particular problem that a is 6. Okay? It just goes right down in order, starting with the x squared. A, B, C. So A is 6, B is 12, C is 4. Okay? And we're just going to substitute them into this formula. We're going to say negative 12 divided by 2 times 6. That's negative 12 divided by 12. Negative 12 divided by 12 is negative 1. Right? And this says you must explain how you got your answer. So I'm going to click negative 1. Explain your thinking. All right, so you're only going to get partial credit if you get the answer correct, but you need to be able to explain how you got that answer. So in this, all I'm looking for is something just like, I know that A equals 6 and B equals 12. So negative B divided by 2A equals negative 12 divided by negative 12 divided by 12, which equals negative 1. Okay, so you just need to be able to explain your work or your reasoning in this. Okay. All right. Next problem. All right. Now the next one, something similar, but this one wants us to actually go ahead and find the full vertex. Okay. So we know that the x value of the vertex and the axis symmetry are the same. So the vertex, we're going to do something very similar. Okay. But this time we need to know that my A because there's no in front of the x squared, my A is 1, the B is 8, and the C is negative 3. Okay? Those are those values there. So when we go to find the x value of the vertex, we say it's a negative 8 divided by 2 times 1. So it's a negative 8 divided by 2, which is a negative 4. Okay, so x value is negative 4. So we already know we could eliminate the second and the fourth option. We know it's going to be negative 4, negative 19, or negative 4, 5. But how do we figure out what the y value is? Okay, well, this is where we take f of, okay, and wherever there's an x, we're going to put in a negative 4. Okay, so where x, the equation is x squared, I'm going to have negative 4 squared. Then we're going to have plus 8 times negative 4, and then minus 3. Okay. Now, you can do that by hand, but Desmos, there's also a calculator that is provided for you if you click right up top here. All right. And I'm going to type it in. Now, notice how I use parentheses here. I'm going to use parentheses on the calculator, especially when you're dealing with negatives. All right. You're going to open yourself up to a lot of errors if you do not. Okay. So I'm going to do parentheses. Negative 4. Negative 4 squared plus 8 and negative 4. And then the minus 3 at the end. Okay, so wherever there's an x, you're going to substitute the negative 4. And we can see your answer shows up right there. It's a negative 19. So it's negative 4, negative 19 is our answer. All right, now, once again, it's enough to be able to do that. But this one says you must explain how you found your answer using the formula x equals negative b over 2a. Or send a picture of your work demonstrating this to me by email. Okay, so you can write it out on a sheet of paper, snap a picture, send an email. But either way, you're going to have to explain your reasoning, right? So what I'm looking for is when you substitute a equals 1 and b equals 8 into the formula, you get -4. Then you have to substitute -4 into the original equation to find the y value. You then get -19 for the y value. Okay. So that's what I'm looking for. I want you to explain what you did, step-by-step process, okay, to get your answer. Then we submit. All right, we got a couple more here. All right. This is the last one in section 8.3. It says identify the y-intercept for the following function. Explain your reasoning for your choice. So once again, you're going to have to explain your reasoning. So the y-intercept, there is actually a couple different ways. One of the things that we talked about, and we talked about it before, is that in the y-intercept, the x value is always 0, right? X value is always 0, no matter what, on the y-intercept. So when you substitute, for instance, if I substitute 0 in for x, we know that 0 squared is 0, and anything times 0 is 0. So we get 0 plus 0 plus c. The c is still there. Well, 0 plus 0 plus c is c. Okay. So the y-intercept, regardless of whatever type of an equation you have, is always going to be the expression that does not have a variable next to it. It's right here, and that's 6. So my y-intercept is 6. Okay, but you got to be careful here. 6, 0, and 0, 6. This would right here, 6, 0, that would be an x-intercept. We don't want an x-intercept, we want a y-intercept. Okay, so you can choose 0, 6. Explain your thinking. And you can just say something as simple as, I know that the c value is always the y-intercept. Okay, and I would take that. All right. Okay, 8.5, right? So for 8.5, we're talking about different types of functions, okay? So we have 3 main different types of functions that we're working with, right? The very first type of function that we talked about this year was linear. The second one was exponential. And the third we're working with right now is quadratics. So how do we tell the difference between them? Well, in a graph, a linear is a straight line. Exponential starts out increasing slowly and then jumps out. A quadratic is a parabola. Okay? Well, now that's all fine and dandy, but how do I tell looking at the graph here? Well, you could plot all the points, or we know that linear, they add the same number each time. Exponential, they multiply by the same number each time. Okay? Quadratics are a little bit different, okay? So it's not the first time. So you have to add, it's the second number. Okay, you're looking at the second time. So for instance, if I'm looking at this one right here, and I'll explain once we get to the quadratic. All right, so this one, I can see I'm adding 2, adding 6, adding a lot. So it's probably not adding in this pattern, but I tell 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. And so I can tell that I'm clearly multiplying each time on this one, right? And so because I'm multiplying, It's exponential, okay? And then you need to explain. Okay, so you can just say I'm multiplying by 3 each time. Or the function is multiplying by 3. You're not necessarily multiplying, right? And then submit your work. All right, next slide. Okay, this one. All right, so we're looking at the y values. So up 6, up 6, up 6, up 6. It's pretty easy there. We know that's linear because you're adding the same number each time. All right, explain. Function is increasing by 6 each time. All right. Choose what type of function the table of values represents and explain why you chose your answer once again. All right. So now this one, I'm going to write it out. So this one, we can see that from -2 to -1, I am adding 1. Okay. From -1 to 2, I'm adding 3. From 2 to 7, I'm adding 5. And then from 7 to 14, we're adding 7. Now, what makes this a quadratic is the second difference. So once we've kind of written these out as +1, +3, +5, +7, now if I look from +1 to +3, we can say to get from +1 to +3, that's +2. Okay, from 3 to 5, that's +2. And from 5 to 7, that's +2. So if the second difference is the same, and so here it is, it's +2, +2, +2, then we can say that that's a quadratic. Okay. So explain your thinking. So the second difference is +2. If you were to also, yeah, so that's essentially what we're looking for on the table of values. The second difference is +2. All right. So we're going to submit that. All right, we got one more slide here. Take a look at this. All right, review session. Right. So if this video wasn't enough, if you still need things to be cleared up, if you want to go over any of the Delta Math assignments from this particular section, join me Thursday, April 23rd at 9:15 for a review session before the test is posted. All right, at 10 o'clock on Thursday, April 23rd, I will post this test and it'll be up from that Thursday throughout the entire weekend. Okay. And we'll go over any questions that you might have before you take the test. The Google Meet link, okay, I will post that on the website. So you'll just need to find that link and then click on that in order to join the session to go over any problems. All right, guys, good luck. Hope to see you at this review session. Watch me try to close So